Hi students, welcome to our physics class. Our chapter name is Fun with Magnets. In the last class, we started this chapter and discussed about some things regarding this magnet. We studied about the history, how we invented magnet. It is actually some myth, but still we studied that. Then we studied what is magnet, which substances attract magnet, and we classified materials into two. And what's the classification? Material, magnetic material, and non-magnetic material. Two types of material. What is this magnetic material? The material which attracts the object. That means the objects which attract towards the magnet is what magnetic material, and the non-magnetic material is the material which do not attract the object. Very simple. Just remember some examples. And then we studied for a magnet, it always have two poles, and we call it as north pole and south pole. And also studied for the magnet different shapes, it is having different names and all we discussed. And so we are on the topic, two poles are the poles of magnet. One is north pole and one is south pole. And the question is this: why we are using this name north pole and south pole? Why we are not using it as west pole or east pole like that? Actually, the thing is very simple. It is having a reason why we are calling it as north pole and south pole. And also something is the ancient people, and still now we are using this magnet to identify the direction. That is, we know there is having north, south, east, west, like directions are there, and that directions and this north pole and south pole of magnet is related. Now we are going to study how these directions are related with the poles of magnet. That is, now we are going to discuss. And so for this activity, I am just taking one bar magnet. In my hand I have no bar magnet, so I am just explaining this. So I am just taking one bar magnet, suspending this using one thread on a stand. This is one stand, and I am just tying one thread on one bar magnet. Suppose this is our bar magnet. I am just tying one thread on this and hanging this on this stand. And now I am going to twist this. That means this is now free to move. It is just hanging on the thread. I am just twisting this and leaving. And so after some time I am just observing this. And then I can see the head. I am giving paint of red here and blue color here. I am just giving some color at the two tips of the magnet to identify the position of this magnet. So this red is at this point and blue is at this point. Now again I am repeating the same activity by again twisting this magnet. That means I am just twisting and leaving my hand from this. And then it will turn back to the initial position. That means again you can see the red region is near this cross mark and this blue region is there at the cross mark. That means how many times I am repeating the same activity, how many times I am twisting this, again always the magnet will be there aligned in a particular direction, always the same direction. Now I am just taking away this magnet and repeating this activity using this duster or some sort of plastic scale or some metal piece or something. And so doing this experiment, I am just tying this using the thread and twisting this and marking where it is having the direction. Again repeating and twisting this, then have I got the same result like the magnet? No, the thing is different. That means for the metal, for the plastic, for the scale, for the duster, when we are twisting this, it will be there in a particular direction. Somehow, whatever, we don't know. We can't predict what is the direction for this. But for the magnet, it is fixed. Whenever we are suspending a magnet on a thread or some sort of thing, it always be there in a particular direction. And when I am comparing this direction with the geographical north and geographical south means for our earth it is having north is there, south is there, west, east, like directions are there for the earth. So I am just comparing this north, south with this direction, and then I can understand that this is our geographical north, and I am calling that this side of magnet is north pole, and here the south, geographical south is here located, and so I am calling this direction of this magnet as south pole. And it is having another name, north seeking pole, and south seeking pole. The thing is this, north seeking pole and south seeking pole means this side always point to north and this side always point to south. Geographical south and geographical north. And the thing is this, as our earth is a magnet actually, and the concept is something different that you can discuss in your 10th standard and so. Now just understand that for a magnet it is having two poles. One is north and one is south, and we can also call it as north seeking pole and south seeking pole. The thing is this, when we are suspending this magnet on a thread, it always be there in a proper direction, and that the northern pole of the magnet always point to the geographical north and the south pole of the magnet always point to the geographical south. So actually that's why we are calling it as north pole and south pole. This is the activity that explained in your textbook. Very simple. And one thing you just want to remember here, this is magnet and that's why it is aligning in a particular direction. When we are using another substances, it will be located any direction. We are not supposed to predict them. Here I can predict. And also one thing is there, in some magnets the north pole and south pole may be crossed out. So at that time I can locate its north pole and south pole using this method. When I just suspend this on a thread, it will align in the proper direction of north and south pole. So this is all about these poles. So I can define this north pole and south pole like this. The end of magnet that points towards north is north seeking pole or north pole. So the definition is this, the end of magnet, actually this north pole and south pole are the ends of magnet. So the end of magnet that points toward north, it always points towards north, geographical north. North is north seeking pole or north pole, and the another one, south pole, is this, the end of magnet that points towards south is south seeking pole or south pole. Similar things we We are only changing north pole and south pole. So these are the definitions. And I already said that travelers use the property of the magnet to identify the directions. I already said that when we are hanging the magnet, it always there in the direction of north, south, and so we can identify the direction using the magnet. And also in your textbook just said that one all China emperor just use one statue on his chariot. That means on his vehicle, he is just using one statue. Statue of a lady is there, and for that statue, its hand is like this. Its hand is just pointing to a particular direction. And the speciality of this lady or this sculpture is this: it changes its direction according to the motion of this vehicle. That means this hand always points to south. The hand of this sculpture always points to the south of the location. That means geographical south. Actually, what is this? This is made of magnet. And here, this emperor used the property of the magnet to identify the direction. On his vehicle, he just put this sculpture and it changes its direction. It is free to move this. It can move to here, and using this he can identify the direction. It always pointed to south. So this is what something that mentioned in your textbook, and the same principle is actually there working for the compass. This compass is not something that we are drawing the circle, not that. Compass means vadakku nokkiyandram. And so, what is this compass? It seems like this. On a circular frame, something is marked there. This NSWE is nothing but the north, south, west and east. Why we are using this compass? The main purpose of compass is to identify the location. It always points to north. So at the center, you can see a needle. You can see a needle. And so the thing is this needle is free to move. This needle is free to move. And so, in some compass you can see here red color is the painted on this head. And that head is what? North. North of what? We already studied that magnet will always point to the north-south direction. So the thing is very simple. This needle is nothing but one magnet. Needle is magnet. And so, as the property of magnet, this magnet's head is north and this is what? South. And so when I am just twisting this frame is free to move. I can move and this needle is also moving, and the thing is this needle always point to the geographical north. That means when I just twist this, the north will come here, south will come, east, west. That means the background readings of this plate will be changed. But always the needle will be here. I will show you what is this compass. So this is one compass. Here you can see a red color is there and that is the north direction. When I am twisting this compass, always this is pointing towards this direction. So that is the north pole of this magnetic needle. And here you can see another side, and this is what? South pole of this magnetic needle. So this is the compass, and this we are using to identify the direction. So now we are going to study what is this compass. Here you can see this is what? Compass. I think it's there in your home itself. There are different types of compass are there. That means the structure is different but the principle is same. The needle is same. Here you can see a red head is there. And that is what? The north pole of the magnet. This needle is magnet and this is not magnet. This is simply plastic frame. And this also plastic frame. The same thing. This red is what? North of this needle. And this is also what? Compass. Different designs of compass is this. And here also you can see what? Something is dancing inside this, and that is what? Our magnet needle, and it always point to the northern direction. That means when I am twisting this, you can see this, the direction is always same. It is not changing. So this is what? Compass. And we are using this to identify the direction. Within this compass, you just want to remember this always points towards the direction north. And the next is you just want to study the definition of compass. Very simple. What is the definition of compass? The definition is this. A compass is a small box with a glass cover in it and a magnetized needle is arranged inside it and it can freely rotate. So the thing is this here, a compass is a small box. I already showed. And so a compass is a small box with a glass cover. It is having a glass cover. And so that's why we can see inside the compass. Glass cover in it and a magnetized needle is arranged inside it. Inside there we can see a needle and I already mentioned that is a magnet. Either it is a magnet or magnetized needle means we are just making it as a magnet. So magnetized needle is arranged inside it and it can freely rotate. It can freely rotate. If it is still, it's not purposeful. So it is free to rotate. So this is the definition for compass. Very simple. I think it's clear for you. And now the next topic is this. Within this definition I said that a magnetized needle. Actually, I am making a particular substance as magnet. That means a particular conducting substance to be there as magnet. So, that is a simple procedure. There are different methods to make a particular thing as magnet. And so, here we are going to study a simple method how we can make one magnet our own. So, make on magnet. For this I need one iron piece and also one magnet. So I will show you how we are making a particular thing as magnet. For this activity I need one iron scale. Actually here I am just demonstrating it using one steel scale. And I need magnet. This is magnet. So I am just taking one magnet and taking the poles. This is the pole. For this magnet, this side is having pole. And so I just want to rub this like this. Not here and there. I just want to move this in only a direction to that side. So I am just rubbing this like this. I am just placing this here and I just want to move this 30-40 times. And when I touch this using a particular pin or something, now you can see, it's not possible to see inside there. When I place this compass here, inside this also one magnet is there, and so that just shake. That means now this scale is converted as a magnet. This is only, it will last for some time, the property of the magnet as a scale. So it will only last for some time, and the thing is this, we can make one magnet using an iron piece and also a magnet. Very simple. We just want to take the iron piece, the magnet, then put the pole on this iron scale. Move. Like when we are doing this 30-40 times repeatedly, same pole on this direction, move, and just rubbing this. When it is continuously doing, what happens? This will convert as a magnet, or I am magnetizing this scale. So this is the procedure to make a particular substance. Here we are using iron. So I just converted this iron scale to magnet. So this is the procedure. So we can say we are just taking a piece of iron. And so the thing is this, I am just taking iron scale, then taking a bar magnet. Or when we are taking bar magnet, it will be more helpful. I have no bar magnet here, so I just used that. So I am placing north here, south. You can use also south and north twisted, no problem. So I am just moving this in this direction, then taking this back. Like I am just rubbing, and after 30-40 times rubbing, this iron piece will convert to magnet, and after some time this iron piece will lose the capacity as magnet, but still at that time when we are just keeping one pin there, it will attract on this iron scale. So this is how we can make a magnet. Now we can make the compass also in our home. That is, just take a beaker, fill it with water, and then take one pin, iron pin, and magnetize this as similar as what we studied on the iron scale. In the similar way, we are just magnetizing this nail, and then take one cork. Cork means rubber cork that will float on water. And so I just put this needle here and put this on the water. It is floating. We just want to make sure this pin is not dipping or touching on water. And when we are just twisting this magnet or this needle will always be there in the north-south direction. So the thing is very simple. Here we can make what? Compass using a needle and a cork with the help of some water. So this is how we can make the compass in our home. This you can see in some sort of films and all. So this is all about this, how we can make compass in our home. Now we are going to deal with the last topic in this chapter. That is, we are just taking two magnets together, again two magnets, and in some cases you just see that these two are getting attached, and in some cases you can see this is moving away. What is the reason? Here also I have two magnets. When I am just putting this, the magnet is rolling in my hand. I don't know, is it observing on the phone? So the magnet is moving. I am not shaking my hand. The thing is this magnet is just jumping on this. So the thing is this, in some cases the magnet, one magnet, two magnet, they are just getting attached, and in some cases they are just moving away. What is the reason? This is actually something depend upon the north and south pole of the magnet. So that means there have some properties for the magnet. There are number of properties are there, and you will study that in your higher classes. Here we are just going to study one of the properties of this. That means in your textbook they just explained one activity using two toy cars. These are two toy cars, and on this toy car I am just sticking one magnet, and here also I am just sticking one magnet using some tap or something. And here I am placing north pole, and this is the south pole, and this also north pole and south pole. When I am placing this, we can observe something, that this car and this car move away. And when I am placing this south pole here, south pole here. So here north pole and this north pole. That means south, south, same poles. Here also you can see this car is moving away. So we can say, I can call this as like poles. That means north pole, north pole. South pole, south pole. They are like poles, similar poles. So for the similar poles, they are not getting attached, they are just moving away. So I can call it as repulsion. Repulsion. So like poles repels. Like poles repels. They are just moving away. That is this repulsion or repels. So for the magnet, generally we are using the term repulsion when two like poles, same poles come together. North, south come together. What happens? They are just moving away. It's not possible to attach this north and north pole together. Never will happen. So this is what north and north, south and south. And now I am going to change the poles of our magnet. Now I am just placing this north here and south. Now our result is something different. That means you can see this is just moving towards and this is just moving towards. That means south and north. When the different poles are coming together, they are just getting together. They are just moving towards. So south and north, they are just moving together. And when I am just twisting this, north, south, here, south, north. That means north, south, north, south. Here also you can see different poles when come together, they are just getting attached together. So this is different, no. This is like poles and this is unlike poles. When unlike poles come together, we are using a particular term, and that is attraction. It attracts. So unlike poles attracts together and like poles repels. So you just want to remember, when north and north comes together, south and south come together, they just repel. And when the south and north and south come together, what happens? They just attract. So unlike poles attracts and like poles repel. This is always like that, and more properties are there, like some sort of lines where the magnetic lines move from north to south. Like different things are there about this magnet. You can study in your higher classes. Now just leave it. So the thing is this, we are at the end of this chapter. And now something is there in your textbook is this. We just want to keep this magnet little more care. That means when we are heating the magnet, it lost its property. One thing. We don't want to heat the magnet. When we heat the magnet, it lost its property. One thing. The second thing is this: when I am just taking one magnet and hammering it, that means I am just taking one hammer and hitting on the magnet, again the magnet lost its property. That is the second thing. And the third thing is this: when we are dropping the magnet from a particular height, there also have the possibility to lose the property of magnet. So these are some of the things that we just want to take care, and also have to be we just want to keep this magnet in a particular manner for the storing and all. Just leave it. Something is there in your textbook, just read it. And one more thing is don't keep your magnets near television, mobile phones, like radio, like all the devices which contains or which produce sound have a magnet inside that. Even if somehow it is permanent magnet or it is temporary magnet, that means some are permanent magnets like this thing. This is permanent magnet. It is always be magnet like this. And some magnets are there that is electromagnet. That means when we are giving electricity, that will convert to magnet. So that like magnets are also be there. Generally we can say whatever the devices that produce sound is having a magnet inside that. Whatever the magnet, doesn't matter. But because of that, don't place magnet near these devices like television, phone, then the like different radio, like things. So this is all about this chapter. This chapter is very simple and also something important because you have to study this further topics in your higher classes. So you just want to study this chapter well. This is all enough for today. We will meet in the next class with further topics. Thank you.